So we are still in this same section of sampling, and unlike the distinction between an experiment and an observational study, this video is about sampling methods, different terminology, how you interpret statistics, and how you might go out and sample yourself. So the idea of making sure that your collection is completely random is ensuring that there is no bias, there is no hidden variable here, that you are speaking to every member of the community of your population, and nobody has a better chance of being selected as being part of the study. And that is not an easy thing to do. Scientists, when they say that it was a simple random sample, they had to have some probably technological method of ensuring that kind of randomness. The concept of a systematic sample is not completely random, but it takes the entire population, it orders it, and then it says, well, I'm going to select every 100th one. And by doing so, I'll make sure that I get a little bit of everyone, right? You see this idea of cars. If you're thinking of a gate or something that every car has to pass through, you could stand at that gate and ask every fifth person. It's not completely random, but what it does is ensure that you're getting a little bit of everyone in the population. A convenient sample is exactly that. It's convenient. So you have to be very careful when you complete a convenient sample that you don't say that that statistic is true of everyone. It's only true of that particular group that you were near or that it was easy to collect from. So it's still a statistic, but you just have to be cautious of what you say the statistic is true for. So we start getting into some real nitty gritty types of classifying. And again, part of this lesson is you're just taking notes and you're trying to identify the sampling method. And part of this lesson is also identifying any sort of bias or any kind of confounding that might occur based on your sampling method or the sampling method that was being used. So stratified and cluster, as you could see from this graphic, both talk about groupings. In a stratified sample, the grouping happens on your own. Like you look at the group and you're like, okay, they're either, part of this group or part of that group, and then you randomly select from each group. A cluster sample, it's as if the population was already grouped and you randomly select groups, but you ask everyone in that group. It's confusing because they're both involving grouping. And so the textbook's got a little tip for you. They say, think about clusters because it starts with the letter C, kind of like your courses or your classes. And as if it would be as if I asked everybody in this class a question, and then you asked everyone in another online class, and then you asked everyone maybe in an in-person class. Right. Again, anytime you do that, you still have this chance that you have to be sure that you are being explicit about who you asked, and when you make your final statement, who that's true of. So the randomized block design is more related to experiments, when stratified sampling is used more for when you're taking surveys, more like observational. And because when you think about the block design, you can also think about this concept of treatment, no treatment, right? Is that I've got these two groups and some people are going to get the treatment and some people are not going to get the treatment. So I know I'm going through these slides very quickly. There's going to be, I'll leave the slides for you to peruse on your own. But it's just different terminology that refers to how scientists get samples of data and, what logistically is possible, and how to ensure that everyone in the sample had an equal chance. And if you don't have the technology and the means to ensure that random sample, that there are other methods to try to make sure that your data is sound and solid.